Okay, so another example of these kind of reverse questions. So again, this part A, when you see that f of some value, that's that f of x that we've kind of been seeing through each example so far. So this is when your x is equal to 2, what is your graph doing at that point? So we go to that x-axis. This is your x value of 2. This is where x is always equal to 2, is that vertical line through 2. And what's your graph doing there? It's at the y value of negative 2. Through all these ups and downs, that's the only spot where it's hitting x equals 2, right? So you've got that ordered pair of 2, negative 2. That's the only point of x equaling 2 that this is happening. So your answer to that's going to be the y value of negative 2. Okay? And then the second question, this one that's the exact opposite of what we've been talking about so far. One value of x for which f of x equals 4. So again, you're looking for your x, your y is equal to 4. So now you're looking at that y value of 4, and we kind of talked about this in the break between videos. There's multiple options here. Now, you don't need to give both. They're just asking for one of those values. So what are my options? Y is equal to 4 at x values of what and what? 0 and 3. So your x equals 0 and 3. You could put either one of those for your answer. Okay? So now number 6, this is kind of referring to the part of 3.4 that we skipped, but I think it still refers to the general idea of graph behavior enough that it was worth us touching on. It doesn't matter that we skipped this part in 3.4. This is relevant enough to just graphs in general that we can spend a couple of problems on it. So all this is asking, increasing, constant, or decreasing? Well, first of all, we can just get right into the first segment. We read our graphs from left to right. Okay, so sometimes when people struggle with this, I try to have them think about time. That's usually a pretty good label to put on the x-axis for us to think about this part clearly. So we're always going left to right when we're reading these. Okay, so think about the slope if you need to. Think about as time passes from left to right, are we going up or down? That's all this is asking. So from A to B, looking from left to right, which direction is our graph going in? Going down, right? So is that increasing, constant, or decreasing? Decreasing. Basically, it has a negative slope, right? That's all that's happening. The next chunk, B to C, what's happening there? That is staying constant. From C to D, increasing, right? We're going up from left to right. And then D to E, that is staying constant again. That's all that's happening in that question. So basically relating it to slope going up, down, or staying the same. All right, then the last type of question, there's 2 of these. So again, these are some goofy graphs that we're going to be looking at that you don't really need to know anything about the function, but we're talking about certain parts of it. Local minimum values of x, and then all values at which x has a local minimum. So I think, so both these examples talk about local minimums. So first of all, what would you assume a maximum value is talking about on a graph? The highest point, right? So maximum is the highest point. So a local maximum is just going to be the highest point within a segment. So it's basically the peak of a turnaround. Okay? So highest point in a portion of the graph. Okay? Peak of a turnaround. Peak of a turn. Okay, that's basically all that that local maximum refers to. So then minimum and local minimum are the same thing. Okay? So then a minimum, speaking generally, if the maximum is the highest point, what's the minimum? Lowest point. Local minimum, and I'm going to try to squeeze this in here. That'd be like the bottom of a turn. Okay? We kind of refer to these as peaks and valleys. Right? So our local minimum maximum are our peaks and valleys. That's all that these are referring to. So what part A is asking, all local minimum values of f. So this is where they want you to actually find the minimum values. These are the two questions that always get us crossed up. All local minimum values. So here you're looking for actual high or low values. These are your y values. So as far as talking about how high or low something actually is, that's talking about the y-axis, right? That vertical axis, how high or low something actually is. So what are the actual local minimum values of f? -3 is a valley. 0, that's the hard part. We always end up looking at the wrong value, and that's a little tricky, I get it. Okay? So our actual low points, the local minimums, where these graphs have a little dip, are at y equals -3 and y equals 0. So that's your y values, 0 and -3. That's where those local minimums, or that's what the local minimums actually are. So then when they ask the question, all values at which f has a local minimum, x value of where those minimums are happening. So these are the x values of where those are actually happening. So you're going to go back to those same values and now just tell me the x values. So the first one's happening where? At -2, and the second one's happening where? At x equals 3. So at which it has a local minimum, they're asking where from left to right is that happening. So that's your x value of -2 and 3. Okay? So last example, same thing. If I were you, they changed the order of these questions. I would always answer what the actual minimum values are first. So all the local minimum values of h, this is your y value. So what is the actual minimum here? -4. So the actual low value for where that's going, for how high or low that's going, is at -4. So the actual minimum value is -4. And then when they ask at which it has a local minimum, so this is your x for where that minimum is happening is going to be what? It's at that x value of -2. So these are the questions that we always mix up because those two wordings are kind of hard to interpret. They are. They're a little tricky to interpret, okay? So that's today. I know it was a little lengthy. Thanks for letting me make the video. And then tomorrow we will get a chance to wrap this stuff up too. We're not going to go right into review test tomorrow. So we will have an extra day in between.